Hello and welcome to NPTEL classes. Today I am here to solve chemistry class 11th NCERT problem 2.32 from unit 2nd, that is structure of atom. Let me read the problem. Part first of the problem is show that the circumference of Bohr's orbit of hydrogen atom is integral multiple of de Broglie wavelength associated with the electron revolving around the orbit. After reading the part first, I got to know that problem is based on two concepts. Number one concept is Bohr's model of hydrogen atom, and number second concept is de Broglie's wave nature of electron. Now we have to show that circumference of Bohr's orbit of hydrogen atom is integral multiple of de Broglie wavelength associated with the electron revolving around the orbit. And part second is based on de Broglie's concept of dual nature of matter. It is also based on wave character of electron. Here we have to calculate wavelength of electron if it is accelerated in potential, if it is accelerated by 10,000 volt potential. Let me practice solution of part first. Solution of part first. Bohr stated in his model of hydrogen atom that electron revolves around the nucleus. Electron revolves around the nucleus in circular path called orbit. In circular path called orbit. De Broglie, in his concept of wave nature of electron, said that electron is a wave. Electron is a wave. It will move in form of crests. It will move in form of crests and troughs. Now we have to show that circumference of Bohr's orbit is integral multiple of wavelength, is integral multiple of wavelength of electron wave. This is crest, this is crest. These are two consecutive crests, and distance between two consecutive crests is called a wavelength. Or if I may label all, this is crest, this is crest, for example, this is crest, this is trough, this is trough, this is trough, this is trough. Now distance between any two consecutive crests or troughs is called a wavelength, and circumference of orbit is circle. Orbit has shape of circle. Circumference, we have to show that circumference of orbit, we have to show that circumference of orbit is integral multiple of wavelength of electron wave. This we have to show. I will use Bohr's second postulate as per Bohr's second postulate. Quantization of angular momentum, he said. Bohr said that electron will move only in those fixed orbits in which angular momentum of electron has quantizer value equal to n8 by 2 pi. This is one of the postulates of Bohr's model of hydrogen atom, that electron will electron is revolving around nucleus in fixed orbit, and for this fixed orbit value of angular momentum of electron is quantized fixed equal to nh by 2 pi. Now angular momentum of electron is equal to product of radius of orbit and linear momentum of electron. R into P is equal to nh by 2 pi, and linear momentum is equal to product of mass and velocity m into v is equal to nh by 2 pi. Circumference of circle is equal to 2 pi r, so I will take 2 pi here and mv I take in denominator. I will get 2 pi r is equal to 2 pi r is equal to nh by mv. Now as per de Broglie de Broglie's wavelength is given equal to h by mv. So instead of this h and mv, I will substitute lambda. I can write 2 pi r is equal to h by, instead of h by mv, I need to write wavelength of electron wave and lambda. So using second postulate of Bohr, that in fixed orbit angular momentum of electron is quantized and has fixed value equal to nh by 2 pi, or else I can say orbit electron will revolve only in those or only in that orbit in which angular momentum of electron has fixed or quantized value equal to nh by 2 pi, and this orbit will become fixed orbit, permitted orbit, or stationary state or energy level for an electron. And I used this statement of Bohr that angular momentum has fixed or quantized value equal to nh by 2 pi. Then I said angular momentum is equal to product of r and linear momentum. Then I said linear momentum is product of mass and velocity. Then I took 2 pi. I had in mind that circumference of circular orbit is 2 pi r. I took 2 pi here and mv in or on RHS side. I got 2 pi r is equal to nh by mv. I used the idea that de Broglie's wavelength or wavelength of matter wave is equal to h by mv. I said that we can substitute instead of h and mv in this equation. In this equation, instead of h and mv, we can substitute lambda. So 2 pi r came equal to n lambda, and this is the statement which we had to show that circumference of orbit is integral multiple of wavelength. So physical significance is that circumference of this orbit, circumference of fixed or permitted orbit or energy level should be integral multiple of wavelength. It should be 1 multiple of wavelength or 2 multiple of wavelength or 3 multiple of wavelength. It should not be fractional multiple of wavelength. And when this condition is satisfied by an orbit, that radius of orbit is integral multiple of wavelength of electron, when for any orbit circumference of orbit is equal to integral multiple of wavelength, this orbit we will label as fixed orbit or permitted orbit or stationary state or energy level, because angular momentum of electron in this orbit will remain fixed, quantized, and energy of electron in this permitted orbit will remain quantized. I will repeat my words. For any circular path, for any orbit, if this condition is satisfied that circumference of orbit is integral multiple of wavelength of electron, then in this orbit angular momentum of electron has fixed value and energy of electron has fixed value. This orbit will become, we will label this orbit as fixed orbit of electron, permitted orbit of electron, energy level of electron, or stationary state of electron. And electron will continuously revolve around nucleus in this permitted orbit. All circular paths orbits will not be fixed orbits or stationary states or permitted orbits. Only those circular paths or orbits around nucleus will be fixed orbits or permitted orbits or stationary states in which this condition is satisfied, that circumference of orbit will be integral multiple of wavelength of electron wave, either 1 times or 2 times or 3 times or n times. And one more significance, when this condition is satisfied by an orbit, one more significance is that the electron wave in such an orbit remains continuous. Electron wave in such an orbit remains continuous. No break in electron wave occurs. There is no break in the electron wave. You see, crest ends in trough, trough ends in crest ends in trough, trough ends in crest ends in trough. There is no break. There is continuity in electron wave, and it means energy of electron, as long as electron continues to remain in orbit, its energy and angular momentum will have fixed value. And we can say that electron wave is continuous, is in phase when circumference of an orbit is equal to n lambda. Electron wave in an orbit, electron wave is continuous, is in phase only when circumference of orbit is integral multiple of wavelength of electron wave. Now coming to part second. In part second, we have to calculate wavelength of electron if accelerated by 10,000 volt. Look here, electron, magnitude of charge on electron is small e, and if we will apply voltage equal V volts, then what will happen? Whenever any charge is present in some field, whenever any charge is present in some potential, and charge here is electron. Electron is charged particle and it is under influence of some potential. It is bound to have energy, it is bound to have kinetic energy, and kinetic energy will be equal to product of magnitude of charge on electron and potential in which electron is present. Let me label this equation as equation 1. What is equation 1? Equation 1 gives kinetic energy of an electron when it is in a force field of potential V, when it's under potential difference equal to V volt. And how much is this kinetic energy? Its kinetic energy is equal to product of magnitude of charge on electron and potential in which it is present. But classical equation of kinetic energy is equal to 1/2 of mv square. This is classical equation of kinetic energy. I will label this as equation 2. Now from equation 2, it is easy for me to write mv square is equal to twice kinetic energy, or I can write V, velocity of electron in an orbit, here I will write velocity of electron in an orbit will be equal to under root of twice kinetic energy divided by m. Sometimes in the problem velocity of electron is not given, so that we can calculate wavelength of electron using de Broglie relation. That time instead of velocity, kinetic energy is given, and from kinetic energy we can determine the velocity of electron in an orbit using this equation, that velocity is equal to under root of twice kinetic energy divided by m. This I will label equation third. From first and third, remember voltage is 10,000 volt. From first and third, I can write velocity is equal to under root of, from first and third I can write velocity is equal to under root of twice, instead of kinetic energy we write product of E and voltage divided by M. I will label this as equation 4. This equation also gives velocity of electron in an orbit, but here dependence of velocity of electron is not on kinetic energy, it is on voltage in which it is present, and magnitude of charge on electron and mass of electron. Now as per de Broglie's relation, lambda, if I need to calculate wavelength, because here in this part second of problem I need to calculate wavelength of electron wave. Wavelength of electron wave is calculated using this equation. Wavelength is equal to h by mv, and this I will label as equation 5. Now I will express velocity in equation 5 in terms of magnitude of charge on electron, voltage and mass of electron. It is easy for me to write lambda, wavelength of electron wave, is equal to h divided by m, mass of electron, into, instead of velocity I need to write 2 into magnitude of charge on electron, voltage in which electron is present, divided by m raised to power 1 by 2. And after simplifying, see, m is in denominator, m is in numerator, but this m is inside square root, this m is outside square root. I will multiply here m, here m. M and m will become m square, square and root will cancel, that m and that m will get cancel. I will get wavelength of electron is equal to h divided by under root of 2 m E and voltage. This is one more equation. This is alternate equation of de Broglie. I can label this equation that it is alternate de Broglie's equation or alternate de Broglie's relation, because from this equation I can again determine wavelength of matter wave, I can again determine wavelength of electron wave, and in part second of the problem I have to determine wavelength of electron wave when it moves under potential of 10,000 volt. Dependence on voltage is inverse. Greater the voltage, less is wavelength, less the voltage, greater is wavelength. And I will substitute values of constants and voltage. Lambda will be equal to h, I know 6.626 into 10 raised to power minus 34. Mass of electron is 9.11 into 10 raised to power minus 31. Charge on electron is 1.6 into 10 raised to power minus 19. Voltage is given 10,000 volt. Or I may write here, wavelength. Wavelength is equal to 6.626 into 10 to the power minus 34 divided by under root of 2 into 9.11 into 10 raised to power minus 31 into magnitude of charge on electron is 1.6 into 10 raised to power minus 19, and voltage is 10 raised to power 4, 10,000 volt. 10 raised to power 4. And on solving I get wavelength. I already done my calculations, and wavelength comes equal to wavelength comes equal to 0.12 angstrom approximately. 0.12 angstrom. I am not sure. You need to first multiply 2, 9.11 and 1.6. Then take its square root. Then divide 6.626 by that square root. And you need to separate. This will become 10 raised to power minus 46. Its root will be 10 raised to power minus 23. It will go in numerator 10 raised to power plus 23. Then after evaluation, you need to find whether answer is 0.12 angstrom or greater than this or less than this. But more or less it will be 0.12 angstrom. Now what is significance of this value of wavelength of electron? This wavelength of electron wave is in the range of X-rays. This is the consequence. This is consequence of dual nature of electron. This is consequence of wave nature of electron. That wavelength of electron is in the range of wavelength of X-rays. Now we will test this consequence like this. Crystal, for example, this board represents crystal, ionic crystal or crystalline solid. Crystalline solid, X-rays are diffracted by crystalline solids, and diffraction is a phenomena associated with waves. And if electron beam is also diffracted by crystalline solid, we can easily say that electron beam behaved like X-rays, because X-rays have wave nature, electron beam will also have wave nature. Or I can say if electron beam is diffracted by crystalline solid, during diffraction being a wave phenomena, during diffraction beam of electron has acted as wave, electron has operated as wave. This confirms that electron has wave nature. And the actual experiment was done by Davison and Germer. They allowed beam of electrons to strike nickel crystal, and like X-rays, electron beam got diffracted and diffraction pattern was similar to X-rays, hence confirming that electron showed the character of X-rays. As X-rays have wave character, electron also has wave character. Or else I can say, because electron beam was diffracted by nickel crystal, and diffraction of electron beam led to the belief that electron is wave, electron behaves as wave. And this idea was electron is a wave. This idea was given by de Broglie. Its experimental verification was given by Davison and Germer, and separately by J.P. Thomson. And together Davison and Thomson were awarded Nobel Prize in order to show for their contribution, in which they showed that electron is a wave. It is behaving like an X-ray, which is a wave. And this whole idea led to the discovery of electron microscope. Electron microscope is like optical microscope. It magnifies the image of an microscopic object, but its magnification is 15 million times greater than optical microscope. And one more difference is that optical microscope utilizes the wave nature of light, but electron microscope utilizes the idea of wave nature of electron. And more importantly, its magnification power is much greater than magnification power of ordinary microscope. Even it will give, even if I will rub these pieces of chalk, the powder which will come out, if I will observe this powder in the electron microscope, it will magnify the image size of this piece of this powder of chalk, and I will get magnified image of this powdered chalk. I can thereafter get to know what is the structure, what is the shape, what is morphology of this chalk powder. This way I was able to finish today's problem. Class 11th students, this is what the problem which I have got for you today. See you day after tomorrow, as tomorrow is turn of class 12 students with one new problem. Allah Hafiz.